Okay, here's another problem for us to work. Suppose you start a company that makes golf balls. You want to sell your balls to the PGA, Pro Golfers Association. For the PGA to accept your balls, they must weigh 1.6 ounces. You sample 20 golf balls and compute a mean of 1.8 ounces with a standard deviation of 0.3 ounces. Use the 5-step method to determine if the PGA might purchase your balls. Test that alpha is 0.05, assume the distribution is normal. Okay, so we are producing this product, and we're hoping to sell it to the PGA, and they say, and I didn't mark all these, they say this is how much the balls have to weigh. So they want you to be 1.6. Now, let's look at this. Is this a less than or a greater than? Well, if the ball's too heavy, they don't want it. Ball's too light, they don't want it. They want it to be exactly 1.6. Different than 1.6. Okay? Notice this is, what kind of test is this? Is this a Z or a T test? I'll go back to black ink. Where's my flow chart? Is N bigger than 30? Nope, 20. Is the data approximately normal? Yes. Is sigma known? Does it say that we have sigma? No, it just says standard deviation. It does not say population standard deviation, so we don't have sigma. So this is a t-test. T-test. What type? This is a two-tailed test. And I'm going to write in red for these two-tailed tests. I'm going to change this right here. Mu equals 1.6. Mu different than 1.6. That's what makes it a two-tailed test. So let's go here. Too heavy. The ball's too heavy. That's not good. If it's too light. That's not good. Okay, so it's a t-test. We figure that out. What do we do with a two-tailed test? We have to cut the alpha in half. Remember? We have to chop alpha in half. What was our alpha? 0.05. So this is 0.025. Now be sure when you do this to make this correct. Alpha over 2 is 0.025. Don't put alpha over 2 equals 0.05, or don't write alpha equals 0.025. Write it correctly. Now our degrees of freedom, and that's nothing special. It's just a t-test. So we have to look up, 20 balls. So degrees of freedom is 19. We're going to reject if the t-value we compute, and we go to the t-distribution table here. So we have across the top 0.025, and then we go down to 19 on the side here, 19 and 0.025, and you find that number there, 19, 2.093. Now, because this is a two-tailed test, you remember this and this matched when it was a one-tailed test. It's a two-tailed test, and every time you have a two-tailed test, you have a greater than and you have an absolute value. That's how a two-tailed test, how it looks different. Okay, now I'll try not to forget 2.093, negative 2.093. Now we compute our t-score. T equals, and this number always goes here. Now, what was our sample weight? 1.8. Our balls are a little heavy. Divided by a square root, 0.3, divided by a square root of 20. So let's see if what we're checking here is if they're within tolerance that the PGA will accept. They're not exactly 1.6 like they want, but is 1.8 close enough to get away with it? 1.8 minus 1.6 divided by 0.3 equals that times square root of 20. And I'm getting 2.98. 2.98. 2.98. I'm going to put that in blue. 2.98 is way out here. That is way out there. That is well into the rejection region. 1.8 is way off of 1.6. They would never buy our balls. So we reject the null hypothesis because there was evidence to accept the alternate alternate hypothesis is true. What does the alternate hypothesis say? The mean of our balls is different than what the PGA wants. And that's true. That is true. So there is one more example. Let's stop this.